to welcome all the working group team of the 3D printing working group, chaired by Olivier Hautefeuille and sponsored by Andy Kane. The working group will describe in more details all the risks connected with the 3D printing and all the underwriting considerations for this type of construction. But before I hand over to Olivier and the team, I would like to draw your attention to small housekeeping rules. We intend to have a presentation of about 50 minutes or maybe an hour, and then we shall have a Q&A session. But to encourage more lively discussion, we are proposing you to ask your questions during the presentations in the chat, and the team could view it and then answer after the presentation. We are planning to upload the presentation on the website after the webinar, and if anybody need the attendance certificate for the CPD or IDD purposes, please contact me or Stephanie. So with this short introduction, I'm finishing here and handing over to Olivier.
Okay.
Olivier, the screen is yours.
Thank you very much, Marina, and welcome to all of you. As Marina said, good morning, good afternoon, or good evening, depending on the place where you are sitting. Here is, rather cold, rainy, and a little bit better after the storm. But welcome to, let's say, this working group. When I volunteered with Andy Kane, to be the chairman of this working group, 3D printing, I thought it would be, like the British say, easy peasy. But very quickly with the group, when we collected intelligence and materials on 3D printing, I discovered that the issue from an insurance point of view was relatively more complicated than I anticipated. And you will see through the presentations, what is exactly the situation of 3D printing, and where we can, make assumptions on the insurance. I have to insist on the fact that this is more assumptions, underwriting recommendations than anything else, because it would have been difficult for us to find, let's say, proper informations on claims, for example. And I do know that claims are an important feature, in these working groups. However, for us, it has been, a difficult subject. So, to introduce you to the group, Mohamed, the next slide, if you want. Mohamed, hello. Yes. So we were, quite a big, strong team. And if we are late in delivering, let's say, this working group, is mainly because of personal circumstances, but we had quite an active group. And we have Tatiana from AXA XL in Madrid, Rodi Munich Re in Munich, so far this is logical, Ernesto Munich Re in Bogota, Arne, in Swiss Re in Frankfurt, Glenn, who is now Munich Re, and I think it's fairly recent, it's maybe a week, but he's now in Munich Re London, but when he joined us, he was QBE at that time, Mohamed from Zurich in Vienna, Simeon from Berkshire Hathaway. I think Simeon had to apologize, I have not seen him, in London, and Rob, who is not with us, I think, in London. Our sponsor is Andy Kane. Andy is head of construction at QBE and member of the EMEA Executive Committee, but also member of the LEG in London. So quite active in the community of engineering underwriter. We divided ourselves in three groups, three parts. One, to concentrate on the economics, just to understand what are the drivers for the construction sector to go towards 3D printing, and this will be presented by Mohamed. The second part will be technical engineering. This was rather vast subject, and we had to, select where we wanted to focus, and it will be presented by Brody. And finally, the insurance, let's say the impact on insurance of 3D printing. This would be presented by Tatiana. You will see with the conclusions towards the end, especially from an insurance point of view, that 3D printing is not yet an easy subject to deal with. And we will put up a certain number of recommendations to you. These are just purely recommendations. I need to insist on this because ENIA is not about, putting up anything else than a good practice for underwriting. So on this sentence, I just want to leave the floor to Mohamed for, let's say, the presentation of the impact on the construction sector. Mohamed?
Thank you, Olivier, for the introduction, and thank you everyone for being here. So, world experts expect a huge surge in demand for housing in the next decades. And just in the next few years only, the world needs 440 million new homes. This represents an immense opportunity for the construction industry to refresh itself and join other sectors in the era of automation, digitization, and optimization. Thus, the new buzzword, construction tech. Construction tech is particularly tangible thanks to the new workforce that is entering construction. It is a generation of construction workers that are tech-savvy and eager for new innovations. In 2018, more than $1 billion was invested globally in construction tech, according to Jones Lang LaSalle. In the past few years, investment in construction tech by far outpaced the overall tech startup growth. We are here talking about artificial intelligence, big data, building information modeling, bricklaying robots, drones, and our topic today, 3D printing. 3D printing in general has made its way into the construction industry under many forms. So experimenting with plastic for architectural models. And on this graph, we can see those would be the yellow spots. Or printing with clay or metal, for example. And those would be on this graph, the brown and dark blue spots. And our topic of today, printing of concrete. And those are the gray spots. 3D printing in construction in general has had a super steep upward slope, and the interest in cement has particularly grown in the past few years, thanks to the large global housing gap and the opportunity smelled by construction companies there. I particularly like this graph and curve because it has a map in the background, and in it, it shows where most of the research and development for 3D construction is happening. Now, here are some of the printers that are out there in the market available to be purchased. Some look like a hybrid between a cement pump and an excavator, a mobile machine on chains ready for the roughness of the construction site, while others look like an overhead bridge crane and are marketed as an off-site printer for parts of a structure, for furniture, for example. Some prices can already be found directly on the manufacturer website, and others are from a website called Aniwa, an online store for construction equipment. And here one can see the Cobot 2, which is a bridge crane for the on-site printing of walls of the building. And I believe this is one of the most reliable and most used 3D cement printers right now in the market. But also on the same slide, we can see the mini printer, which is with its small pump for the 3D printing of pots or outdoor furniture or even art. And the price here is attractive in comparison to others, and that could be a reason for it to gain faster popularity among cement subcontractors. And on this slide are some of the top players that are heavily involved in this innovative new niche. A lot of them are relatively new startups, but some names like Sika are already very familiar in construction and especially in additives, and that is why it makes sense for them to be here. So as one can see, there's a lot of interest and activity in this space. However, it is not without its challenges. I'd like to touch a bit on some of these challenges here. Those are typical challenges, really, for any new type of innovative technologies at their nascent stage. As we've seen in previous slides, those machines are still expensive for the average cement subcontractor. And that is maybe why this new technology is still not immediately adopted by them. These challenges are being addressed, of course, and each day there are some improvements in the 3D cement printing space, but it is still not problem-free. In the next few slides, I'll address the issues of cost saving, and I'll do that by first comparing 3D printing in manufacturing to 3D printing in construction. So as you can see from this slide, in a factory, the printers are in a safe, clean, enclosed location. In manufacturing, the same product is manufactured over and over, which means the software needs to be programmed just once. And the input material is stable and constant. The printer is part of an already automated chain. 3D printing is just an optimization of an already automated process. Well, that is not the case for construction industry. First of all, the printer would have to be transported and set up over and over again for every new site. It's out in the open, it's in the rough and rugged conditions and vulnerable to nature. For each new structure, the printer would need to be recalibrated and the software reprogrammed. Only the cement pouring part is automated in construction. A lot of the other processes are still not automated and still need human involvement. Therefore, optimization is still a few steps away. So theoretical research on cost and time will tell you that 3D cement printing is extremely effective. Unfortunately, some current academic research, but especially online articles, are filled with hyperboles and sensational rhetoric. I talked to the customer relations managers at Cobot, a more serious and successful 3D cement printing maker, and they admitted right up front that it is still more expensive today to print cement than it is to pour it. And he joked about how some of their competitors falsely advertised the cost and time effectiveness of the 3D cement printing, and then got flooded with phone calls from people asking them to come over for the weekend to print an extension of their home in the backyard for $4,000. The technology is obviously still not there, and this misinformation hurts an otherwise healthy, growing new technology that just needs its time to properly develop and find its space in the construction sector. The technology is still improving, and after printing several identical structures of the same design, you start benefiting from economies of scale, and it should become cheaper to print than it is to pour cement. This graph shows how steep the interest in the 3D cement printing is developing. Despite the challenges, it's still quite a sensational growth. And Kobod, one of the more serious companies building 3D cement machines, and that was able to already have a cooperation with GE to print wind turbine towers, are receiving on average around 1,000 inquiries per month. Now, he admits that the hit ratio is still very low, around only 0.5 percentage point conversion rate. However, the interest is definitely out there. And as it is typical for successful startups to have such an exponential year-on-year growth, especially in their early stage phase, they are selling about 8 times this year what they sold last year. So I believe that in the short and medium run, 3D cement printing will give birth to a new category of specialized cement subcontractors, those that manufacture parts of the structure off-site. And I use the word manufacture here to draw a parallel with the manufacturing companies that have so successfully adopted 3D printing. The next long-term step would be the widespread adoption of 3D cement printers by the average cement subcontractor, once it really becomes cost-effective. 3D cement printing still needs to improve so that it can optimize the construction sector. And I believe that with a bit of time, it will. Exactly how construction will be fully automated is still not 100% clear. This will unfold the next few years, and 3D cement printing is certainly at the center of this revolution. And with that, I pass on the floor to Brody, who will now go into the technical details of 3D cement printing. Thank you.
Thank you very much, Mohammed, and a warm welcome also from my side to everybody. I'm Brody Willis, and I've been working with Anna and Ernesto in the technology subgroup, and have the pleasure to present our outcomes here. So when we first started researching, we saw a lot of different definitions, and we'll just jump to that next slide, where it was a bit confusing how to actually define construction 3D printing. And so we decided to go high level and found an ISO, an international standard on 3D printing, which obviously covers more than just construction 3D printing. It covers all types of 3D printings. And there's a definition there, which basically talks about deposition of material. Also defined is additive manufacturing in that paper, which talks about joining material. And we found actually that these two terms are used interchangeably. So a lot of the times when we're talking about 3D printing, maybe something's not being deposited, but it's being joined. Actually, we're talking about additive manufacturing. But even the standard, this ISO standard itself talks about that the term is used interchangeably. So that definition helped us out, but then we saw lots of different types of 3D printers and materials, and even just in the group discussing it, we had a hard time trying to fit in the different pieces. So the next slide shows us just a bit of an overview of how we classified it. There's no general standard how to classify it, so it's not really an agreed standard how to classify it, but we found basically 3 main areas. You can either classify 3D printing for construction with the materials, so either something that's cementitious or aggregate based, plastics or metals, or you could classify it by the printer type and setting, and by that it's meant, is it a robotic printer, is it a gantry printer, is it on-site or is it off-site in a factory? And then finally, the last classification that we sort of saw was the technology type of the printer. So as the technology type was sort of the overview of the different things, where you can then certainly break it down into the materials and maybe printer types. We also found a paper that depicted the different technology types that's also defined by ISO. There's 7 different technology types that are listed there, and not all of them are applicable to construction. So, for example, that photopolymerization, that injects a thermoplastic under a liquid in a really small sort of area. So it's not really applicable to us. The ones that are applicable will go into further details in the next couple of slides. So one of the main areas that we see in construction 3D printing is material extrusion. And there are also different types of printers there that we can classify based on the materials now. And the primary one that we're looking at here, of course, is with the cementitious or aggregate-based materials. So it doesn't have to be necessarily cement. It can be clay, or even organic material is used to form that extruded material. And one point down there, just something that it's a term that was coined back in the early 1990s, contour crafting, and that relates to when the material is extruded from the print nozzle, that there's a trowel that you see in that picture, just that yellow bit of plastic that then forms the external surface of that concrete in a way. But there's countless other types of extrusion printers out there, and each company has their own type of setup and design. So that's the one we're going to talk about mostly today. Some other extrusion printers use, for example, polymer and different type of plastics. And a term there is the big area additive manufacturing. And basically how you can think of that is just you probably know those small printers, the 3D printers you see in the shops. Those things are just giant versions of that, that just extrude thermal melted plastic, and then that's the way you get your extruded material for your construction. So generally here the size is also limited, so it'll be precast in a factory, then transported to site, and maybe used for facade elements and the like. And then finally we have this quite complicated multi or composite material extruded printers, which use different types of material. And in this case, the photo shows the BattyPrint 3D technology, which has a nozzle which first deposits a polyurethane foam, which acts as a formwork, and then another nozzle, once that's set pretty much instantly, the other nozzle fills the infill with self-compacting concrete. So you end up with a dual material hybrid extruded material 3D printed structure in the end. So those are the 3D printing types we see with extrusions. There are other 3D printing types of construction that are talked about in the next slide. And one of them, of course, is binder jetting. And this is a bit different. It uses a bed of sand, and even some cement is sometimes included. And the 3D printer then goes across this layer of sand, and either adds just some steam to bond the areas that need to be 3D printed, or it adds some sort of type of adhesive or emulsion to stick those pieces of sand together, and then it will deposit another layer of sand and keep doing that until you end up with your full structure. And the picture on the right there just shows something used more for a creative artwork type structure. But we've also seen that that binder jetting used for bridges. So there is some potential in there, but obviously the size of the printer and the size of the members that are printed are somewhat limited. Now, powder bed fusion uses a similar technology, but rather than having a sand and cement mix, it has a sand and metallic mix, steel mix. And then the printer head just fuses this material together with extremely high heat, and you end up with a metallic 3D printed structure. For example, here we see a picture of a space frame node that was created with this process. And interestingly, and we can touch on this maybe later at the end, is the 3D printing allows a lot of these complex forms that aren't able to be made with traditional casting. So using the current technology, they've actually optimized this design using stress and strain, took out everything that doesn't assist in the structural performance of the structure, and it ended up with a shape that looks slightly organic even. So that's powder bed fusion. The final one, direct energy deposition, basically you can think of that as a robot welding machine. There's two different types here. The laser metal deposition 3D printer fuses just, again, metallic powder together, whereas the wire arc additive manufacturing, or WAM, is similar to your arc welding, where there's a metal wire that gets melted by the extremely hot laser there. So those are some other technologies that are used in construction, and the rest from the 7 aren't really applicable. So that gives an overview of the printer head, but maybe just to show you how this whole thing works from a higher level, the next slide shows first off how the design can work in a simple form, and then how it actually works on site or in the factory. So once you have your 3D computer model of your structure that you want to 3D print, this has to be then converted into a mesh, sort of like a triangular mesh, and there's a standard file format, STL file, but there's other formats as well. And so that just basically takes your 3D solid model into a mesh file, and then you need a slicing software, which you can imagine as like an egg slicer. It just cuts that model into the small layers, which you see in that picture, the fourth on the left. And then you have your layers then, but there's another step which then needs to be made, usually automatic, but generally also quite labor intensive, which tells the printer the tool path. So which way does it have to go to make sure that he can build that 3D model. And so there might be an algorithm that goes across and gives you 80%, but there's some manual labor there that says, all right, that doesn't make sense for the toolpath then to automatically move from one corner of the building to the other corner. So they'll make some modified and adjustments there. And then the next step is just send it to the printer, and then you get your 3D printer on that picture on the left. The picture on the right shows you how it looks on the site or in your factory. So you have your computer, which has the file and the slice and the toolpath. And it has to talk to, which is point 1 there, and that has to talk to the controller of the robot arm and the print head. And now the interesting thing is that you know, the robot arm and print head don't necessarily have to be the same manufacturer. You can have different OEMs producing those, so it's quite complex what the controller has to do. It not only has to move the arm at the right speed and the right location, but the print head has to then extrude the right amount of material with the right mix. So on the right there, you have 7 and 8, which sort of talks about the wet cementitious mix, and 5 and 6 sort of talks about your additives, which will go into further detail. So that mix has to be spot on from the print head, and combined with the movement of the robot arm or a gantry printer, that's how you end up with your number 9, which is the extruded structure. So that's just the higher level overview. And the next slide talks about some of the key challenges that's involved here. And there's 2 parts, especially when we're talking about the cementitious extruded 3D printing technology, which is one, the cement mix, or the cement concrete mix, which is a lot more, and we'll go into this in further detail, but it's a lot more specific than your standard Portland cement 25 MPa mix that you order from your pre-mix concrete factory. But the other part is in reinforcement, and to get this done automatically is quite interesting. There's different methods to include your reinforcement. And if you remember your basic engineering stuff, concrete is good in compression, and but you need your reinforcement to give it the tensile capacity and ductility. So let's just park those 2 things. Those are the 2 challenges associated with the sort of materials that go into 3D printing. But then the next slide just points out also some of the process challenges with the technology. And these are things like not just in terms of the reinforcement, but then the next slide talks about automation in general. So is it just a plug and play? Setup where your experts on the field can push print on the computer and the 3D printer just runs by itself? or does there need to be the manual intervention? Does reinforcement need to be added manually? Do the hoppers need to be added and that sort of thing? So the more we can move to automation, the better it gets, but the more complicated it gets. There's this point about geometric freedom, which basically means if you have a robot arm 3D printer, it might be able to do the corner of a house, but you probably will have to move that to the other corner because just the radius of what it is able to reach, isn't that high. The flip shot of that is if you have a gantry mounted 3D printer, it takes a lot longer to set up, mount your gantry and cranes. But once that starts going, you have the full geometric freedom there to finish the house without having to set up again. There's a point there about process speed. So it's quite critical that your concrete doesn't get extruded too fast, which doesn't ensure your layer and smooth profile of what you're extruding. But if it goes too slow, your concrete will it might clog up your nozzles and that. So there's some aspects involved with there, which is quite complicated. And then the final 2 points just talk about just the technology in general. And you can imagine with robustness, if something goes wrong while you're casting your 3D building, for example, it would be quite challenging to get it if you need a spare part or need some technician out to look at your printing process. So the 3D printing process has to be quite robust so that it doesn't break down mid-pour. And the technology maturity level just talks about, well, if everything is automated, it's great, but a lot of the things are still a bit sort of hybrid where parts are automatic and other parts are still quite manual. And we'll look at next the concrete mix and some of the challenges with that. So we touched on this before, and there's sort of aspects of concrete that talk about flowability, your early strength, and to make sure that when the next layer goes on top of the old layer, that it's strong enough to support that layer on top and the weight on top. Otherwise, you'll get a quite early failure in that. And so the way it happens on site is there's a lot of research on this as well and a lot of papers being written, but it seems to be quite an iterative process. So that means that the designers will come up with a mixed design with different additives and super plasticizers and accelerators and all those sort of things to make sure that the mix is just right. But then once you're on site, there's different conditions, humidity and sunlight and all that sort of stuff. So it's an iterative process, which means they have to do a lot of tests. They've got to check to make sure it's fine. And even during casting or 3D printing of a structure, they might have to make small adjustments to the printhead to take extra, water cement ratio or add more additives or remove the additives, just basically on how it's working. The interesting thing is that there are some concrete and cement providers that have sort of said, okay, we know what the industry is going towards. We'll provide a somewhat standard mix. But again, it's as all the different the providers of these 3D printers have their proprietary systems. At the moment, it seems like everyone's just working on their own special concrete mix. But at least it's working, and there have been lots of case studies with concrete mixers and getting these structures done. That's not necessarily the case with automatic installation of reinforcement. So the next slide shows some of the difficulties there. At the moment, and what we're seeing is that the reinforcement, whether it be a wedge or a steel bar or some ties that just connect the two different sections together, that is being done manually. So there's a manual labor going around, including the tie rods, as the 3D printer is working, which, I mean, it sort of defeats the process. We want a fully automated system that just prints house after house. So there's some different methods that are being looked at, whether it be including a parallel steel wire during the casting with a spool, or adding different smaller fibers that are inside the extruded material to give it that tensile capacity, or other things that just shoot the bars in while it goes along. So there's different things being investigated, more so at university level, and I guess in conjunction with the main 3D players, because this challenge is probably the main one that everyone is focusing on, is how to get the reinforcement process also automated. So that sort of shows it in terms of the technology part. One of the biggest challenges, though, doesn't have to do with the physics and the engineering. The biggest challenge is the standards and regulations. And what the issue is that, okay, so a lot of the standards and regulations around the world, they don't exclude 3D printing, so that's the good thing. But they don't necessarily have special standards for buildings that are made through 3D printing process. So what generally has to happen is that the developer, in conjunction with the 3D printer, have to go through and get a building approval demonstrating that the 3D printed house meets the standards and regulations that are in that region. It's just the standard ones that any other house would do. And the challenge there is that there's no experience then on the side of the government that's approving this, and so it'll be brand new. There's also not a lot of experience. It's starting to build, but with the consulting engineers. So, you know, the consulting engineers that will work for a 3D printer and demonstrate through their finite element method that the ultimate strengths of these walls are adequate, that's all fine. But then on the authority side, they don't have anyone there to be able to say, well, is it fine or not? So that's probably the biggest challenge. There are some ways that the main regions in the world are trying to deal with it, and the one that's probably the most proactive is this this ICC standard, the International Codes, the ICC. So they've proactively said we need acceptance criteria that helps these 3D printing developers demonstrate that they meet the International Building Code, which is that model code in the states, so that in USA that different states then can accept or not. But this acceptance criteria on the right here shows different things. So it's not just about your design, but it's then doing testing. So you've got your standard compressive stress and all that sort of stuff. But then it's also fire resistance, your inspection requirements, your quality assurance, and quality control. So that provides a good guideline of how these 3D printing companies can get through this important issue of standards and regulation. The challenge, of course, is if you go through the hurdle with one authority and build a house in one region, as soon as you build another house through the next authority, you've got to start from scratch and try to demonstrate to them that it's okay again. So that is probably one of the biggest challenges here with seeing this mainstreamed. Now, another important factor here is that I just want to touch on is sustainability, which in this day and age cannot be left out. So we've looked at that in terms of your standard, triple bottom line: environmental, human, social, and economic. And we found that it's not a clear cut. It's not a clear cut where you say, okay, 3D printing is definitely sustainable and it's gonna solve everything. It's a balance, right? So obviously we discussed this lower costs in the previous section. So hopefully we'll realize that in the short to medium term, and that would be great. So that will provide access to more social housing and provide access to housing at all if that gets achieved. The other part is that due to the less material that are used with 3D printing, it's generally always fairly optimized as opposed to just cast in situ concrete. Therefore, you have less CO2 emissions. So there's a big plus there. The other point is because you're not having this formwork and other sort of temporary works involved with 3D printing, there's also less waste. which also reduces CO2 emissions in that case. When you automate these processes, obviously you have some human social benefits, so reduced injuries and fatalities on construction sites. And with time savings, the comment there relates more to being able to quickly build houses for any sort of future, let's call it disaster events or humanitarian events. So that's on the positive side, or maybe on some of the sides that still need work. It will interrupt the supply chain, well, the traditional, let's say, the incumbent processes of just cast in situ traditional building of houses, and all the supply chain that goes with that. There is still some question about the reliability of the materials. It hasn't really been around that long, so there's always a question, well, will it last the 50 years that your traditional buildings have lasted? And the last point is quite an interesting one. It talks about, well, the equipment to get this 3D printing is quite expensive. So if the idea is to build cheap social housing in developing countries, that really puts a big hurdle on getting that technology in over there. It won't really allow self-development of that because of the high startup costs. So that's just a few points in terms of sustainability, and we're going to finish up my section just with some key case studies and flagship projects. And the first one here is probably the largest 3D built structure, 3D printed structure in Dubai. And you know, it was built in within a few days, and with extreme conditions. So they built it. They printed mostly at night time. And what's interesting here is that you can get quite interesting architectural forms. You know, curved walls were always a nightmare for civil engineers. So with 3D printing, you can get quite free-form structures happening. So that's an example where you can get a complex structure built in a short amount of time. The example on the right is actually a whole development that was built with 3D printers in Mexico, and this has been completed. There's some, I'm not sure if that's I think that is actually a real picture, and the difference here is that you can get a simple design and you can build these houses within 24 hours. So these 50 houses that were built in the development were built really quickly. So that's sort of the contrast between complex versus simple. The next slide talks about maybe even going a bit more in terms of sustainable approach and low cost housing. So on the left, we have a house here in India that was printed with the 3D printer, and that was also done 2-story, so a bit larger than our case in Mexico, and also quite quickly built. And then the example on the right, talking not just about concrete, but installing it based on other materials, in this case, a clay mix that was sourced locally. So if you're sourcing local materials, clay, there's another example from the same company using rice husks and sort of like the old brick materials, and using a 3D printer with local source materials cuts out all that transport costs, the inbuilt carbon in the cement and all that sort of stuff. So those are interesting cases. The final one, which is a bit closer to home here in Munich, just shows you that you can get houses built with 3D printing that sort of mimic and look very similar to the houses that you just see down the street. So the previous examples, you can sort of look at it and go, okay, that's a 3D printed house. It probably has not the same quality or the same standards as a normal house. Well, here in Germany, the Perry and Cobalt printer, you can see the gantry setup on the right. They've printed this 3D this 2-story house, and as you can see, it can quite easily disguise itself as a traditional house, and the quality would be quite similar. So potentially that it shows us what is the future with this 3D printing. So that's it from me. I will hand it over to Tatjana next to talk about underwriting considerations, and look forward to the discussions later. Thank you.
Thank you, Brody. Thank you, everybody, for being here. My name is Tatiana, and I'm going to guide you through this risk analysis and underwriting part. Mohammed, yeah, thank you. From previous chapters, we can conclude that this 3D printing technology has not reached yet an industrial deployment. So that's why we say these 3D printing machines are prototypes and the end product is innovative, mainly because of the quality of the mixes. So this is innovative, but it's also a reality. We have seen a lot of examples of projects that we have already in the market. We have printed units in factories, we have printed units on site, and even we have construction of repetitive building shells on site. So that's why we think this is an important topic for underwriters to be aware of the technology and to analyze the risk and the insurance perspective. And as Olivier said, our aim is not to fix or to give a fixed guideline to the underwriters, but just to give some recommendations and highlight key points to be analyzed. So this is not only a specific topic for engineering underwriters, but this will also impact other kind of policies. We can have construction and erection policies, IDI, construction defects, general liability, and also PI and cyber. So the main points to be considered, for example, in a construction or erection policy, we should consider the experience of all the involved parties, also the specifications of the projects, and also QA/QC procedures. In the case of IDI, we are not sure about the durability of these structures. So the life expectancy will be something not clear yet and something challenging for this kind of policies. The same for construction defects. This is a more specific policy in the United States, where they are used to work with timber frame and where this 3D printing technology will be something quite new. Regarding liabilities, general liability policies, it's also something unclear, the responsibility between the parties. Here we have, for example, the software designer, the printer designer, the mix supplier, the contractor, and it's also not clear the performance of the structure in the future. So these kind of policies will be challenging too. Regarding PI, we can have different kind of defects that can appear during the construction or even in the future. So this cover will be also a key point. And the latest is the cyber liability. If we link the digitalization of the construction sector with CAD and BIM softwares with this 3D printing software, we can have a higher cyber exposure. So these kind of policies will be also very important. And in previous chapters, we have seen a lot of examples for housings, but I would like to say that this is not the only kind of projects that we can have with 3D printing technology. We have here two real cases for two small bridges. And yeah, we are not sure, but probably these projects have been included in our clients' programs. So that's why the underwriters should be aware of the technology and pay attention to this new technology, because probably they already have the technology and this kind of projects in their portfolios. So in the next slide, Mohammed, please. Yeah, so it is true that when we want to learn about, no, the previous one, please. When we want to learn about a specific technology and how to to analyze it as from the insurance perspective, we look at the claims, but in this case, we have a lack of data, and that's why we have worked on different scenarios. We want to distinguish between two phases, the construction phase and the post-construction phase, and look at different issues we can find. During the construction phase, we can find defective mix, printer malfunctions, or even issues with the software compatibility. And during the post-construction, we can find crackings, insulation faults, or even issues with the durability of the structure. So in the next slide, we want to highlight some points for the underwriters. First, during the construction phase, we can look at 3 different parts where we can find issues. The first one is the printed item itself, the procedure. So we can have a defective mix or any other kind of defects. So that's why it's quite important to look at the design cover we want to include. We don't want to say if leg 1 or leg 2 or leg 3 must be included, just to say that this must be analyzed. And also we recommend to include a serial loss clause, as we can have several losses arising from the same event. And for that purpose, an adequate deductible will be also important in order to avoid frequency. The second part is the machine itself. This is a very specialized equipment, and the replacement or the spare parts cannot be so easy access it. So that's why we can have a CPE coverage for those cases where we print on site, and for those cases where we have the printing machine in a facility, in a factory. We could even have a separate risk policy with a machinery breakdown cover. And the third part is linked to the software. As we have said, the design for the software must be compatible with the printer, and this 3D printing technology can lead to a more sophisticated design. So the cyber exposure is clear. We must include a cyber exclusion in our policies. And we can also imagine even a combined clause with this cyber clause exclusion and also the electronic equipment insurance. On the following slide, we can see some key points for the post-construction phase. So in order to avoid finding cracking or mixed effects, the QA, QC procedures, and even a resurvey is very important, and depending on the information we get during the underwriting process, a maintenance cover could be included or not. Again, we are not saying which one, but just something to be analyzed. Another point to be considered is the possible unfitness for purpose, especially for those near zero emission buildings constructed with 3D printing. And this is a special topic for IDI and PI policies. And the latest are the contractual liabilities. We recommend underwriters to stay away from these contractual liabilities, as the responsibility between the parties, I have said, is not clear. On the following slide, we can find some other recommendations. Like, for example, delaying startup cover. This is another cover to be considered. We are not saying if it can be included or not, but the analysis should be done in a different way, as this 3D printing technology is increasing productivity but also decreasing timing, and the underwriters should look after the mixed supplier and also pay attention to the replacement of the of the equipment. And also here with aggregation clause, we want to say that limits and SAR limits should be aggregated not only for post-construction, but only during construction. We can find defects and several losses arising from the same event. So we think this is another important point to be considered. And in the following slide, we can see that this is not only a matter for the underwriter, but also for the risk management perspective. As we have said, QA/QC standards need to be addressed during the underwriting, but our understanding is that 3D printing still follow the current QA/QC frameworks for buildings. And as we have said, there is no room for improvisation, so our clients should check the experience of all the suppliers, all subcontractors. And just to mention a special case, for example, in the IDI policies, the technical inspection service must have enough experience with 3D printing technology. So that's all for my part for the underwriting part. And now, Olivier, the floor is yours again.
So you can understand a little bit more the introductions in a way that when we started to dig into 3D printings, we could see the innovations and, let's say, the industrializations process all together. And for us, we had several discussions about how to approach this technology. But before we conclude, let me check. Mohamed, could you go to the next slide? So what we have learned in a certain way, the concept economically makes perfect sense. This is something that we cannot deny. This 3D printing will be on the market as certainly one of the solutions that the construction industry is currently developing. And from a demand side, there is a perfect logic there. From the other side, i.e. the offer, the contractors, the engineers, and so there is also all the arguments for there. And there is also something that we had to consider, and which is quite the subject of many discussions today, is the need to deliver on time and on budget. And basically, 3D printing would certainly give more, let's say, certainty over these two items, when it would be fully developed. This technology, we say that is still being developed and so, but we have given you a few examples of industrial use already, and especially simple housing, affordable housing, but also more complex structure. And we will certainly come back on this during the Q&A sessions. But the tuning are quite, important. And we had, let's say, some discussion with Richard Buswell, who is civil engineering professor at Loughborough University. And when we talk about QA/QC, they are perfectly aware that in this, context, without, framework on QA/QC, without the framework to allow risk surveyor to do the job, it will be difficult for somebody like us to develop underwriting. But the things that Tatiana pinpoint is that this will have a real impact on all the lines of businesses linked to construction. So IE is not just a subject of CAR, EAR, but inherent defect, general liability, professional indemnity, cyber, the cyber risk will increase. So basically, 3D printing is, a subject that underwriters, need, really to consider and to work on. Mohamed? So, what we would certainly encourage the underwriters, the member of the EMEA, is with or without the broker assistance, depending on the relationship and so, but really to start to engage with, the client. We have seen in this presentation that you have specialized, equipment producer, Cobalt. We could have a specialized product from Sika, for example, but we have also, some in-house technology being developed by the largest contractor. So we need to understand, how they are projecting themselves into 3D printing. We didn't talk about Vinci or Bechtel or, other big contractor, large contractor, but we know, that they are working and, certainly financing research on this technology. The problem is this is a kind of a competitive advantage that they are developing, and therefore, if they communicate through a press release, they don't give too much details about the solutions that they are currently work. We also would like to put up a recommendation for, let's say, the EMEA committee and the EMEA associations. When we come to 3D printing, where we are at the borderline of the innovations and, scaling up to industrial process, it's important that we develop a watch. So I don't know how to do it, and so this is more for the executive committee to decide, but to maintain a watch on this technology. The group I was part of struggled to find, example, on 3D printing. Not in a way that there is no, let's say, literature about this, but very often the same example are coming, back into the different publication we have seen. And the things which is maybe not just 3D printings, but has maybe been discussed also with, let's say, modular constructions, which was, the group before us, is how we could adjust the traditional CAR wording to a process which is more and more industrialized, in a way that we could have, back the issue of all risk property and machinery breakdown, this type of even electronic equipment insurance. So this type of things needs maybe to be reviewed, and not, for tomorrow, but the future will certainly lead the underwriters to, reflections on this wordings, which currently is the same wording as I used 30 years ago. So to give you an idea of my age. So this is our main recommendations. We wanted to show you a small video. I don't know if we can launch it. We know that there is a problem with the sound. So maybe what you could do, Mohamed, is to launch the video, and I will tell you when to stop if we don't have the sound. Okay, this is, we do not have the sound, so we are very sorry for that, and we have to apologize. But you know that the conquest of March and the future missions of sending men and human beings on Mars is hot topics. And the NASA launched a kind of competitions about what would be a base on Mars. And the funny things that appear, during these competitions is that they opted for 3D printing. And in fact, what you see here is, you know, relative to what Brody say about the quality of concrete, and so it does resist in a certain way, in a good way, for certain pressure, but not so much into, let's say, the overpressure. So here you see a shell that you know, is being built to protect, in fact, let's say, the astronaut or spationaut or cosmonaut, depending on the country you are living in, from the radiations. And within this space, you will have, you know, a laminated structure, PVC or whatever, something certainly more modern than the material I refer to. But what we see on this full movie is 3D printing with robotizations, with a full set of, you know, the technology that construction is being working on today. So I believe that it will be better quality on, you know, on the website, when it will be on the website. But you see here some example of robots that can, you know, recognize, let's say, the topography, recognize, let's say, the ground conditions, dig out the ground conditions, treat that, and then, you know, use it with a kind of, let's say, a 3D printing mode to create this external shell that we have seen earlier on. This is 3D printings, for example, there. So you do see that this kind of, you know, design, which have been finally, let's say, retained by NASA, as is an example of where the construction will be aiming at, even on, you know, on Earth. So we wanted to show you this in a simple manner, you know, just for your information and all these kind of things. But the good things, and maybe if you can go to the next slide. So the good things is thanks to, you know, everybody, and thanks to the group, this risk is already placed. And this is the, you know, the things that I wanted to say is thanks to Tatiana. She has accepted 100% of the risk. Then we have Brody, 100% on behalf of Munich Re, Ernesto, 100% of the risk, and Arne, 100%. Unfortunately, Glenn has accepted 100% when he was at QBE, so these things is on the QBE book now. I know that few executive committee members will be pale, but this is, you know, just for, let's say, the future. And Zurich, Mohamed has done it. We have Simeon from Berkshire Hathaway. We have, you know, Rob on behalf of insurance. So this is, you know, special thanks. I don't think that the executive committee should be worried too much about, you know, this acceptance. But I wanted to you know, say a special thanks to the underwriter who have been working on this group. We have not yet finished the paper, and the paper will be released certainly beginning of next year, and will certainly be also considering the questions that you may have in the Q&A sessions. We need also to thank, you know, a few other external contributors. And can you carry on? Yeah. So one is Richard Buswell from Loughborough University. In a certain way, Richard worked indirectly on the project of the NASA, and is a kind of leader in the technology of 3D printing. And in UK, certainly one of the let's say, the academics that is pushing the technology and so on. We have to also Thanks, Mr. Vytautas Naslenas of Cobot. We engage several times with different manufacturers and academicians, and this is how we got the information that allow us, to push, let's say, a little bit the boundary of this working group. I need also to thanks. And of course, AZ Studio, we are, let's say, the designer of the, let's say, the colony on Mars, and the NASA to have launched, this kind of study to see how this could be the future of, a colony on the red planet. And of course, we cannot forget Andy, and most importantly, Stephanie. Stephanie has been our organizer, our timekeeper, everything. The one that was behind, let's say, the scene, but always there for us. And I want to say a special thanks to all of you, and hopefully, if you have any questions, we are ready to answer them. We have in the, let's say, in the following part of the presentation, but it's no need to speak about it, is key acronyms and reference to various documents that we have, read and investigated, and so. I think the best way now is to take up a few questions from the audience.
So Olivier, just to step in, people can raise their hands if they have a question, and then we shall allow them to speak. So,
okay.
Stefan, you raised your hand?
Indeed, I did. Thanks, Stephanie, for noticing. First of all, very big thank you to the entire working group on behalf of EMEA and the executive committee. It's a brilliant presentation, I must say. I'm duly impressed. I know it's always taking a bit longer when Olivier gets involved, but that's because he has very high standards. Yeah? On the other side, I can assure you that as a representative of the executive committee or board of directors in the future, I'm not worried at all. I'm rather excited. I'm excited to receive the first submission for insurance cover from March. Yeah. But I honestly and seriously, I'm also grateful for the hints and the food for thought you're giving. So we will take those recommendations up in the committee. I'm always very happy if we get that kind of feedback, what EMEA can actually deliver more, what we can do in addition to what we are already doing. And I think like an idea like implementing a permanent working group on all kind of innovations is certainly a good thing to do. Yeah? To always keep the new inventions in mind. And of course, those working groups and the whole EMEA actually only lives and is dependent on the participation of all its members or anybody else who's interested in doing it. So that at the same time is a call for any people who would like to volunteer to participate in such a working group. And secondly, about the wording, yeah, I think there are many wordings which are 30 years plus old, and they all need to be reviewed and looked upon again. But it's a good point. And I think we should adapt to the needs of modern construction, changing construction as well. And so I'm proposing to take that up together with the LEG group. Andy Kane happens to be in the LEG group as well. So that fits very well, actually, I would say. And maybe together we can come up with something. So again, just wanted to tell you, we are not frightened, we are not worried, and we are rather very thankful for these recommendations. So thank you very much.
Thank you very much, Stefan. And I know that this innovation and the progress, of technology is something that you have at heart. So this is, something that the underwriter within this, let's say, group will certainly be pleased to assist and to carry on to work on. Yeah. I've seen. I have one question, maybe just to launch, let's say, the Q&A sessions, and maybe to give a little bit more body, to 3D printings. On one stage, Mohamed, you talk about a wind farm partnership between Cobalt and GE. Can someone, speak a little bit more about these things? Because here we are not talking about housing, we are not talking about civil engineering, but we are talking about something totally different.
Yes, and I believe we have a few photos of that as well in our presentation. So here it is. That's being printed inside, behind closed doors. So we don't have a lot of technical information about it, or at least I couldn't find any, but I do know that Cobalt and GE signed a contract, an agreement, and they are planning on printing several of those as a new way. Maybe the technical group has something more to add on that.
Yeah, I can maybe jump in there. So the reason that they were looking into printing these pedestals for wind farms is that for larger height wind farms, the size of the base would be so wide that they wouldn't fit on the back of trucks to be able to transport. And constructing them in situ on site with cranes is also quite complex, especially with the form and shape and the tapering of the. So the idea is that if you can get a 3D printer that's sort of self-supporting and has a structure that's structurally sound while it's printing, you'll be able to get that happening on site without having to transport large pieces, but secondly, achieve a lot higher heights than that you usually see with these wind farms. So that's sort of the background there, and it's still just, I think, in the testing the concept, whether it makes sense and whether it's feasible. But if you can imagine just a 3D printer crawling up and building its own tower, I think that's quite an interesting case study.
We have a question that Andy typed in. Can I read it to you guys?
Please.
So what are the benefits of 3D printing concrete elements off-site versus other robotic concrete manufacturing that involve pouring rather than printing? Are they economic or technical?
I guess the question's comparing just a standard precast concrete facility to a factory-based 3D printer, and the only thing I can think of there is the geometric freedom that's allowed with the 3D printing. A traditional casting, a precast, and you see this with precast construction. All the buildings that are precast are nice and square. With my tunneling background, you've got precast that do the segments, which are a bit curved, but that's quite difficult to get those curves all automated, and there's quite a lot of manual stuff that goes on in there. Although it is quite automated as well. There's more like a factory process line. So I think the main reason there is the geometric freedoms that are given by the 3D concrete printer. Now with concrete, with concrete printers, the reason you have a factory rather than on site is that within a factory you can have the pretty much standard environment, so that you can control your temperature, humidity, and all that sort of stuff, and your supplies of the cement. Whereas on site it's a bit more difficult. So that's the reason you'd go in a factory with 3D concrete printing. But yeah, probably the factory, you'd see the other types, either maybe with plastic or metals to keep that in controlled environment, or some of the other non-extrusion technologies that we've talked about. So maybe D-shape, the binder jetting, or the welding stuff.
Okay, no more questions in the chat box. If anyone else has a question and would like to ask verbally, just raise your hand and
No.
I have one question concerning the defects coverage. Do you see any problems with the defects coverage here? So I'm talking about the wording issues. Will it be possible to examine and understand what should be the perfect coverage here? Can we talk about some defects extension or maybe defects exclusion? Are there any recommendations of the group?
Tatiana,
Yeah. Our understanding is that this defects clause must be adapted to the project and also to the experience of the involved parties. So we are not saying that you must include a specific one, but it depends on yeah, I think the experience and also the type of 3D printing machine you are using, the mix and the type of process. So we cannot say if you must use one, for example, like 1 or like 3, or if you must exclude all defects. Yeah, it is up to the underwriter and to the experience of the involved parties.
just to complete maybe the point made by Tatiana, I believe that when we will publish the paper, we will ask a legal opinion about how to apply, you know, this design coverage or design exclusions to, you know, the technology of 3D printing, because we discussed a little bit within the group and we decided not to raise too much without this legal opinion. But the limit between consequences and faulty parts are blurred, if you want, with the process. So we have to be careful. And one thing that Tatiana mentions is that the technology, the piece of equipment in itself is prototypical, you know, the 3D printing machine. When the end result, the mix and the let's say the product is a different matter. So we like something which is proven or prototypical, but here in this instance we mix a little bit the technology with the end result, let's say the product, which made us a little bit uncomfortable to make a strong positions on this matter. But it's something that we will need to ask, and certainly with Andy, if we can have access to, let's say, a legal opinion from EMEA about this particular issue, it would be nice.
Mm-hmm. Thanks very much. To be honest, I also have the same opinion here, because it's very complicated to understand where it was the defect in material or in design.
Mm-hmm.
We have a question from Tim Chapman. With the example shown, how would you achieve the tensile strength?
So, I declare myself incompetent. I'm too old.
I can try to answer this one, but maybe we need to hand it over to our concrete expert, Arne. Yeah. So what's interesting with this 3D printing as well is that you can form these structures that act a bit like 3D trusses in a way. So I think that assists. You can see the sort of squiggly line in the middle, which would act as a truss, and so that helps. And I assume that there's some sort of fiber reinforcement or other steel bars in there that we can't see at this detail that assists, because I don't think a tower like this that would expect to hold a wind turbine would be completely unreinforced. But again, if Arne wants to jump in, and you're on mute, Arne.
Right. Thank you. Yeah, jump in. The thing is, the most advantages if using 3D printing with regard to reinforcement would be the use of fiber. This might be steel fiber. It might be polypropylene, depending on the strength you would like to achieve, or carbon fibers. And some of the pictures Brody showed were about the incorporation of fibers or bars into the freshly printed material. So I assume fibers, to what extent and which form and which geometry might be the biggest advantages in the use of 3D printed concrete with regard to some kind of structural purposes. So, but what has been done until now is laying bars or sometimes even mesh into the freshly printed material. So, but I would assume fiber would be the future. That's pretty much it from my side.
What we can see through this example and with the questions from a team is that we use less material. If you have to imagine that this would be built in a normal conventional way, you would have certainly much more material than the design we can see here. And we have maybe some other slide to show you. So another example where we have this specific, this is a metallic frame which I think Brody used in one of the slides. And again, this metallic part show you exactly the same purpose, the same use, but how 3D printing achieve the same engineering purpose with less material.
No more questions at the moment.
I click. So we are just on time, for the end, the conclusion of this webinar. Am I correct, Stephanie?
That's right, yes.
Yeah.
So perfect timing.
Perfect timing. So on my behalf, thank you on behalf of the Digitalisation group and my behalf, thank you to everybody to have been present. The slides will be on the website, I assume. We will remove, let's say, the internal use only comments. This was internal use for the working group, but we'll remove these mentions. This should be available on EMEA website. And for Marina, informations, we intend to release the paper, certainly by the end of January. We will let Christmas and New Year pass by, and then the paper would be there with additional, information on the questions.
Thanks very much, Olivier, and again,